Hey everyone, I am going to start today's lesson right where yesterday stopped. So this is the second day of section 1.1. So your last example should look like what you see right now. We finished through G, so I'm just going to start right where we left off. We will finish the rest of the examples for section 1, and then you guys will have an additional homework assignment for section 1 through big ideas. So once again, just go right to where your notes stopped. You should be looking at this problem. This is the last one we did yesterday. We're going to jump right into more examples. Okay, so these are more one-step, or what we would consider one-step equations. They're just getting a little more challenging. So now we're going to look at what we do when we have fractions. So we have 2/3 times a equals 4. So the way we undo multiplying by a fraction is we actually multiply by the reciprocal. So we are going to flip this fraction, so 2/3 becomes 3/2. We're going to multiply both sides of the equation by that fraction. Remember, when you're solving an equation, anything you do to one side, you have to do the other side so that they stay equal. Okay? So the reason that we do this is there's kind of two explanations for it. The first one is that here we can cross cancel the 3's, cross cancel the 2's. It leaves you with one A, so the A is isolated. The other reason that this makes sense is the whole keep, change, flip idea. Normally we undo multiplying by dividing, but remember, when we divide a fraction, we actually just flip it and multiply. So same idea here. So you can think of using inverse operations, or you can think of what would isolate your A, what would give you one A. So either way, just multiply both sides by that reciprocal, kind of the long explanation, but hopefully it helps make sense. So anyway, on the left side, we are done with those fractions. We have A equals, we have to either cancel or multiply across the top, multiply across the bottom. Either way, you end up with A equals 6. So if I was doing this problem and showing all my work, which I should be doing, I would write it like that. And then you can go ahead and just change that to a 2, change that to a 1, and then 2 times 3 is how we get the 6. All right, if you need more time, pause the video. If not, we are going to continue on. Here's the next one. So we looked at some like this yesterday too, where you have to sort of clean up the signs before you get started. So I am actually going to rewrite the right-hand side. So 13 equals W minus a negative 21. We know that minus a negative is the same thing as plus. So we are going to just rewrite it, and then it's a lot easier to see what the inverse operation would be. So if I want to undo adding 21, I'm going to have to subtract 21. So on the right-hand side, your 21s are gone. You just have the W, which is good. The variable is isolated. On the left, we have 13 minus 21. So you're going to subtract the numbers, keep the sign of the larger number. So it is a negative 8, and W equals negative 8. All right, here's our next one. This one, these are always tricky. This is actually a two-step equation. So this is more like what we're going to do tomorrow, but it looks like a one-step equation. That's why we throw it in with this lesson. It's kind of tricky. So the first thing we want to tackle in order to get the A isolated is the 15. Now, right now, this 15 is positive, so you could actually think of it as a negative A plus 15. That might make it a little easier to think about how are we going to get rid of this 15. So the way we get rid of that 15 is we are going to subtract 15 from both sides. So he's gone in the front. You got to keep the negative with the A. All right, this is one term, negative A. So negative A equals 2. That's where I'm at now. Now, it looks like the A is isolated, but it's not. It is negative. So the way we undo multiplying by a negative is we just divide both sides by negative 1. So this will get rid of our negatives. We just have the A equals, and then that'll be a negative 2. Again, that's a tricky one, more like a two-stepper, which we're going to cover tomorrow. So be careful on that one. All right, here is K. Now, normally when I see parentheses, I'll have to distribute. There's nothing to distribute though. There's no coefficient. If you want to distribute a 1, you can. You're just kind of doing work that doesn't really matter. These parentheses are basically just here to slow us down, okay? So I am just going to pretend they're not there, and I'm going to combine like terms. So 7 plus 2 is 9. All right, and now it's just like a regular one-stepper like we talked about yesterday. So instead of adding 9, I want to undo the adding 9, so I'm going to subtract 9 from both sides. Cross those out. And then 1 minus 9 is going to be a negative 8. All right, here comes our next one. I'm going to slow it down a little bit on this one because I know those fractions take a minute to write out. All right, so before I can do the whole multiply by the reciprocal thing, we talked about reciprocals when we were doing that first chapter 1A. You can't multiply fractions when you have the mixed numbers, okay? So we need to first change these to improper fractions. So we're going to do 3 times 2, that's 6, plus 1, that's 7. So 7 thirds, x, and then when we multiply over here, we do the 7 times 4, that's 28. 28 plus 5 gives me 33 over 7. So first, make them improper fractions. We cannot do much with mixed numbers. Now, students are often like, which one do I flip? You have to remember the whole point of this is to isolate the variable. So if I want to isolate this x, this is the fraction that needs to be flipped. Okay, so I'm going to take the reciprocal of 7 thirds and I'm going to multiply both sides by that. So flip it, multiply both sides. We have 3 sevenths and 3 sevenths. All right, on the left side, those are going to go away. We're just left with the x. Now, over here, I kind of was like, oh, the 7s will cancel out, the 3s will cancel. They're not going to, though, because, look, our 3s are on top and our 7s are on bottom. So we can't cross-cancel anything. The 7 and the 3 do not simplify. The 33 and the 7 do not simplify. So we are just going to multiply our numerators. So 33 times 3 is 99. Multiply our denominators. 7 times 7 is 49. So kind of a tricky one. All right, moving right along. Once again, this is almost one we could do tomorrow. This is more like a two-stepper, but still it's just a lot of combining like terms, which you already know how to do, distributing, which you already know how to do. So we can go ahead and tackle this one today. So the first thing that I need to do is handle those parentheses. And they are being multiplied, or the terms inside are being multiplied by a negative. This is like a -1. So I need to think of distributing a -1 to each term inside my parentheses. So I'm going to rewrite the 3 equals -2. Then I have a -1 times x and a -1 times a -4. So that's going to become a plus. Okay, and again, once I hit the next step, that my writing goes away. I don't particularly love that about this program, but that's what I did in between. So I just distributed the -1 to the x and the -1 to the -4. Okay, now I can combine like terms. So I have a -2 and a +4. So those are going to go together. So -2 plus 4. That's going to be a +2. So I'm going to rewrite those together. The x is still negative, so just leave that guy alone. And some students are like, well, how come I didn't just subtract 4 and then add 2? That's not a wrong way to do it. That's just more work than you need to. Anytime you have like terms on one side of the equal sign, that's what you need to be focusing on. Okay, so now all my like terms are combined. I need to get rid of the plus 2. So I am going to subtract 2 from both sides. So 3 minus 2, that's going to give me 1. And then I still have the negative with the x. So I need to divide both sides by -1. These are going to go away. I just have my x, and then a +1 divided by a -1 is just a -1, but we always write the variable in the front. So x equals -1. That was a long one. This might be a good place to stop and really compare your work to mine. Make sure you're getting this. But we actually are on our last example for today. So like I said, the one-steppers go a little quicker. Once we get into the harder equations, these lessons might take a little longer, but we will get there when we get there. So right now I have a fraction 3/4 times a, and that equals 2/5. So I need to multiply by the reciprocal. So the reciprocal, that's with the variable. So the coefficient of the variable. So flip it. That gives me 4/3. So I'm going to multiply both sides by 4/3. 4's go away. 3's go away. I'm left with a on the left side. And then I'm going to multiply my numerators. 2 times 4 gives me 8. Multiply my denominators. 5 times 3 gives me 15. And that is where we're going to stop today. We are going to look at word problems. You can see if you're following along in your book, you can see there are some word problems towards the end of the homework, but we're going to tackle those a little later. So right now, your job is to go to big ideas, just like you did yesterday, and work through that homework assignment. Now, I am putting on there that you get 2 additional attempts on each problem. You also have access to a live tutor and some hints. Some of you, I looked at your homework from yesterday and your scores were not good, and then I looked and you hadn't even used any of those resources. So if you are getting stuck, there should be options on there to ask for help from a tutor, to see a worked out example, or to try a few more attempts. So you should be using all those resources while you're working through your homework. That's why the online homework is so much more helpful, I think, than just writing it in your book, because then you don't have those options, especially while we're remote. It's really good to use those resources. So click around in the book as you're going through it, and let me know if you guys have any questions. We will start with our 2-steppers tomorrow. I will talk to you then. Bye, guys.